Leaving a taped-up hot three-phase cable hanging out of a machine to the ground is not proper by code. It is a serious violation of electrical codes and poses significant safety hazards. The correct procedure should be followed to ensure electrical safety and prevent potential accidents. The National Electrical Code, or NEC, has requirements concerning this. NEC Article 110.15 requires that all electrical equipment and conductors be installed in a neat and workmanlike manner. NEC Article 409.11 states that ungrounded exposed live parts of AC circuit shall not be accessible to unqualified persons. NEC Article 430.10 requires that the wiring of electric motors be protected from physical damage. There are multiple hazards with leaving a hot three-phase cable hanging loose. Firstly, there is the hazard of a cross-phasing explosion. If the cable were to come into contact with another circuit, it could create a cross-phase explosion, which could cause severe damage to equipment and injury to personnel. Secondly, there is the hazard of electrocution. Anyone who comes into contact with the exposed conductors could be electrocuted. Thirdly, there is the risk of an electrical fire. The taped-up cable could overheat and start a fire. The proper procedure when a motor is removed from a machine is as follows. 1. Disconnect the circuit breaker supplying power to the machine. 2. Remove the wiring from the motor terminals. 3. Cap or seal the unused conductors to prevent them from contacting other electrical components. By adhering to these steps, you can ensure a safer electrical environment. Leaving electrical wires exposed can lead to many consequences. For example, consider a scenario where a worker is performing maintenance on a nearby machine. Unaware of the live wires, they accidentally brush against the exposed conductors. The result could be a severe electric shock, potentially leading to cardiac arrest or other life-threatening injuries. Or consider the scenario of a small child wandering into an area with exposed electrical wiring. Children are naturally curious and may touch or play with the wires, leading to electrocution or severe burns. Furthermore, the exposed wires could come into contact with flammable materials, such as cardboard boxes or oil-soaked rags. The resulting electrical fire could quickly spread, causing extensive damage to the facility and endangering the lives of those inside. Cross-phasing can occur when two or more electrical phases come into contact with each other, resulting in a short circuit. This can cause a sudden surge of current leading to an explosion. This type of explosion can be forceful, throwing debris and potentially injuring anyone in the vicinity. The heat from the explosion can also ignite nearby materials, leading to a fire. To mitigate the risk of exposed wires, it is crucial to ensure that all electrical work is performed by qualified electricians. These professionals have the knowledge and experience to safely disconnect and terminate electrical circuits. Additionally, they will use appropriate safety measures such as lockout-tagout procedures to prevent accidental energization of the circuit while work is being performed. Regular inspections of electrical systems can also help identify and address potential hazards before they lead to accidents. These inspections should be performed by qualified personnel who can identify exposed wires, damaged insulation, and other electrical safety issues. Any identified issue should be promptly repaired to prevent accidents and ensure the safety of all workers. In addition to the NEC requirements, OSHA also has regulations regarding electrical safety in the workplace. These regulations require employers to provide a safe working environment for their employees, which includes protecting them from electrical hazards. Employers are required to implement safety programs, train employees on electrical safety procedures, and provide appropriate personal protective equipment. By following these regulations, employers can minimize the risk of electrical accidents and ensure the safety of their workers. Electrical safety is a shared responsibility. Employers, employees, and electrical contractors all have a role to play in preventing electrical accidents. By working together and following established safety procedures, it is possible to create a safe working environment for everyone. Remember to always prioritize safety when working with electricity. If you are not qualified to perform electrical work, do not attempt to do so. Instead, contact a qualified electrician who can safely perform the work for you. This will help prevent accidents and ensure the safety of yourself and others. The NEC is updated every 3 years to reflect the latest advances in electrical technology and safety practices. It is important for electrical professionals to stay up to date on the latest code requirements to ensure that their work meets the highest safety standards. Continuing education courses and professional development opportunities can help electricians stay current on the latest code changes and best practices. The taped-up cable may seem like a minor issue, but it can have serious consequences. By addressing this hazard and following proper electrical safety procedures, you can help prevent accidents and ensure a safe working environment. Always remember that electricity is a powerful force and should be treated with respect. By taking the necessary precautions, you can work safely around electricity and avoid potential hazards. The integrity of the tape itself should be a consideration. Over time, electrical tape can degrade due to environmental factors such as temperature fluctuations, humidity, and exposure to chemicals. When this happens, the tape can lose its adhesive properties and become brittle, potentially exposing the conductors it is meant to insulate. This is especially concerning in industrial environments where machinery can vibrate and cause the tape to loosen further. Furthermore, some types of electrical tape are not rated for outdoor use or exposure to harsh chemicals. Using the wrong type of tape in such environments can accelerate its degradation and increase the risk of electrical hazards. It's also important to consider the way the tape was applied. If the tape was not applied properly, with sufficient overlap and tension, it may not provide adequate insulation. Gaps or voids in the tape can allow moisture and contaminants to penetrate, leading to corrosion and electrical failures. A poorly taped connection is essentially an invitation for problems down the line. Beyond the tape itself, the condition of the conductors within the tape bundle is also important. If the conductors are old, corroded, or damaged, the tape may not be enough to prevent electrical hazards. Damaged insulation in the conductors can create leakage paths for current, leading to shocks or fires. Corrosion can increase the resistance of the conductors, causing them to overheat and potentially melt the tape or surrounding materials. Therefore, it's crucial to inspect the conductors themselves before relying on tape as the sole means of insulation. The location of the taped cable is another critical factor to consider. If the cable is located in a high-traffic area where it is likely to be bumped, sagged, or otherwise disturbed, the risk of damage is significantly increased. Even if the tape is initially intact, repeated physical stress can cause it to loosen or tear, exposing the conductors. Similarly, if the cable is located near machinery that generates heat, vibration, or chemicals, the tape may degrade more quickly, compromising its ability to insulate the conductors. The surrounding environment plays a significant role in the long-term reliability of any electrical connection. To properly address the situation with the hanging cable, it's essential to follow a systematic approach. Firstly, to energize the circuit by turning off the appropriate circuit breaker. This is the most important step to ensure your safety. Secondly, carefully inspect the cable and conductors for any signs of damage, corrosion, or degradation. If the conductors are in poor condition, they should be replaced entirely. Thirdly, remove the old tape and properly insulate the conductors with appropriate materials such as heat shrink tubing or insulated wire connectors. Fourthly, secure the cable in a safe location where it is protected from physical damage and environmental factors. Use cable ties, clamps, or other appropriate hardware to keep the cable out of harm's way. Fifthly, clearly label the cable to indicate its purpose and voltage. This will help prevent accidental contact or misuse in the future. Sixthly, document all work performed, including the date, description of the work, and the name of the person who performed it. This documentation can be valuable for future maintenance and troubleshooting. Finally, test the circuit to ensure that it is properly functioning and that there are no electrical hazards. Use a multimeter or other appropriate testing equipment to verify that the voltage and current are within safe limits. Remember, electrical safety is not just a matter of following codes and regulations. It's a matter of common sense and responsible behavior. By taking the necessary precautions and following proper procedures, you can protect yourself and others from electrical hazards. Always prioritize safety when working with electricity and never take shortcuts that could compromise your well-being.